So we're talking about angles. So for this, there's a different vocabulary that you need to know and how to write an angle. So in this case, it says an angle is formed by two, the new word that we're talking about today is rays. For a ray is different from a line. A line continues in both directions forever. A segment is a piece of a line, so it has two endpoints. A ray has one endpoint, and then it continues in one direction forever, whichever way it's going. And it has a common endpoint. That's what's creating an angle. The common endpoint is called the vertex. So if you look at your picture over here, the vertex is technically point B. And it has two rays that are forming it. So ray BA and ray BC are coming together. They have a common endpoint. That's creating the actual angle itself. The rays are called the sides of the angle because you have two sides that create an angle. They come together to make an angle. And then you can name an angle. You can name an angle using three letters. So notice in your picture, you have three letters. You have A, D, and C. The middle letter, the key is the middle letter must always represent the vertex. So there's two different ways you can write your angle. I can start at A, go to B, end at C, or I can go the opposite way. I could start at C, go to B, and then end at A. So we're going to write it both ways. We're going to say this is angle ABC. Or I could say angle CBA. Either way, that vertex B is in the middle of the combination ABC, CBA. Back in middle school, 7th grade, I think, you really dealt with angles. You were introduced to angles and different types of angles. That's whenever you were dealing with one angle. For geometry, we're never going to just have really one angle. It's going to look more like this. You're going to have like a combination of angles. So you're never really going to have one angle by itself because you can't really do much with that. But if you do have one angle, you can also use a single letter if there's only one angle, which is the vertex. So I could say like angle B because there's only one angle in this picture. When referring to the measure of an angle, we use a lowercase m. So the measure of angle ABC is equal to 60 degrees. That's just telling me the total for this is 60, the interior angle. So now we're going to talk about types of angles. Let's go back to 7th grade. A refresher. Does anybody remember what this little tiny baby angle is called? It's a cute. And that's because it's less than 90 degrees. So between 0 and 90, it's an acute angle. It's cute and it's tiny. It's a baby. What about the next one? Obtuse. Because he's obese. He's obtuse. This is between technically 90 degrees and 180 degrees. Technically, it could be more than 180 degrees, but we'll say normally it's between 90 and 180. So anything bigger than 90. And then this one, it has a little square. That is a right angle. Automatically, if you see this square, if you don't remember this, the square means that it's equal to 90 degrees. So it's not less than 90, it's not more than 90. This is equal to 90 degrees no matter what, because the square is a right angle. And then this Akko Taco one that's like just laying out, this is a straight line, which is 180. So a straight line automatically equals 180 degrees. Half of 180 is 90. That's why it's perfectly going up and it has a little square. If it looks like it's 90 degrees, but it does not have the square and it doesn't say it's a right angle, you cannot assume that it's 90 degrees because it might be 88 degrees or 89 degrees or 91 degrees. So if it doesn't have the square, don't assume it's 90. So let's talk about the first example using our vocabulary. So based on this picture, I need to name the vertex of the angle. So what is the vertex? Okay. I need to name the sides, which are the rays. So for example, I'll show you how you're going to write this. If I say KL, I have a little dot and then I have an arrow that represents ray KL because it ends and it goes on forever. It has like a start and then it goes on forever. What is the other ray? You could say KJ, and you could also say it the opposite way if you're thinking JK because you want to do it in alphabetical order. That's okay too. It can go opposite. I could say LK, JK, KL, whatever, not KL. Yeah, I could say KL. So I can go back and forth. It doesn't matter. 3 ways to write an angle. The first way is the most easiest, which is just angle K because there's only one angle in this picture. The other 2, you have to use all 3 letters. So for the next one, I can say JKL because the vertex is in the middle. JKL. What would be the last way I could name this angle? LKJ. K is still in the middle. It's just going the opposite direction. LKJ. And then I'm going to classify the angle, which means what type of angle is this? Obtuse. So take a minute and try to fill in the next example using the vocabulary. So try to fill in the next example. Try to figure out what the vertex is. Try to figure out how you're going to name the sides. You quit? You quit math? Yeah. Oh, okay, good. Don't quit math. Okay, let's talk about it. So what's the vertex for this one? S. The sides, you could say 2 different things. You could say, can anybody tell me one of them? SR. That's perfect. And then what's the other one? ST. And if you said them backwards, that's also okay. There's 3 different ways to name an angle. So what's one of the ways? Angle S. Angle RST. What's happening? What's the last one? PSR. And then what type of angle is this? Right angle, because you have that square automatically means 90 degrees. Okay, so let's talk about congruent angles. Congruent is the same as last chapter. Congruent means that they are equal. So the symbol for congruent is an equal sign with a squiggle on top. That means that they are equal parts. So if I say that the measure of angle A equals 75 degrees, and I also say the measure of angle B equals 75 degrees, then the angles are congruent because they're both 75 degrees. If you look at your picture, they're both 75. A is 75, B is 75. Then what I can say is that they're congruent. The way I would write this is that angle A is congruent to angle B. The higher math you go, the lazier we get. When I took Calc 1, 2, and 3, the higher you go, the less words we write. We were writing like full-on sentences without any words at all because we're lazy and we suck at spelling. Hey, you guys are back. I never signed the paper, so we're still doing that? Yeah. Okay, do you mean like after school? Or like, wait, what? Yeah, I have, that's my planning period. It's after this one, 4th. Okay, yeah, come back. Bye. What's up? Somebody's out, so when they come back, I don't think the pass is over there. But when the pass comes back, you can go. Okay, so on the back, I'll leave it up here for a second. On the back, we got 2 more things. I know you guys are like feeling it. We have 2 more vocabulary words we got to talk about, and then we're going to get into the math. So we're going to talk about on the back an angle bisector, which is a new term, and then perpendicular lines should sound familiar to you. Perpendicular lines you should have talked about in 8th grade, and you should have also talked about it in Algebra 1. So the new thing is angle bisector. So on the back side, an angle bisector is splitting an angle perfectly in half. So it's making 2 congruent pieces. So on the back, an angle bisector is making 2 congruent pieces. So this is making congruent angles. So what we're going to say is a ray that divides an angle into 2 congruent angles is creating an angle bisector. So if I look at this picture, I have the large angle ABC, the ray BD. So in the diagram to the right, BD is a ray. So I'm going to draw a little endpoint with an arrow. It is an angle bisector because they're telling me it's an angle bisector. Therefore, these 2 angles are congruent. If I said that this was 30 degrees, this little angle ABD, then that means DBC would also be 30 degrees. So I'm going to say, therefore, angle ABD is congruent to DBC, angle DBC. So if this was 30, then this would be 30. The entire thing is going to be 60. The big angle would be 60 because I'm splitting them into 2 equal parts, 30 and 30. That's the kind of I was going to say Pythagorean theorem. That's the postulate we're talking about today is segment addition postulate. So we're going to take the small pieces inside and we're going to add them to make the big piece. Perpendicular lines, this is when 2 lines cross to make a 90-degree angle. So 2 lines that intersect at a right angle. The symbol for perpendicular, which you should have seen last year, this should be familiar, is an upside down capital T. An upside down capital T represents perpendicular. Like I said, math people are lazy. So instead of writing the word perpendicular, we were like, an upside down capital T because it's creating a 90-degree angle. In the diagram to the right, we would say line is perpendicular to line M. Yeah, go ahead. Yeah, when you guys back go. If the path is here, just take the path and go. Just be time cautious so other people can go. So angle addition postulate, this is where we're going to get into the math. What's up? Yeah. Yeah, when I'm standing in the back of the room, I can't see for anything at all whatsoever. I'm like blind. So angle addition postulate is where we're going to take the small angle on the inside and we're going to add it to the other small angle. So we're going to say this one plus this one equals the whole thing. So that's what angle addition postulate is underneath this. So I'm going to show you kind of in colors what it means. You don't have to use colors if you don't want to. But we're going to say it says the measure of angle ADB. ADB is this small inside angle, ADB. I'm going to add it to BDC. So if I start at B, go to D, and at C, if I add the 2 inside angles together, that's going to create the whole exterior angle, which is ADC. So if you follow the letters as it's written, it tells you what angle you're talking about. From A to D to C is the entire exterior angle. I have my 2 interiors adding together to make the exterior. So I want you to take a second after you add your little colors if you want. Try to read example 5. Try to see if you can find the missing angle measure in the information that's provided in the student. The picture in your picture that they tell you So try to set up example 5. Put your information in your picture. WST is 50 degrees. So you should put 50 in that little angle that they're telling you this.
Don't have to set up an equation with the fall because people just add it or subtract it.
So they say if the measure of angle WST is 50, you should have put 50 here. The measure of RSW, if I start at R, I go to S, go to W, is 125. They're saying this whole thing is 125. So the entire angle is 125. I need to find, or what is RST? So I'm trying to find this. I'll just put a little X because it's math class, so we need variables. So there's X. What am I going to have to do to find that angle? The whole thing needs to be 125. So subtract it. So I'm taking 125. I'm subtracting 50. So what do I get? What? 75. So the way you write your answer is the measure of angle RST equals 75 degrees. Because if the whole thing's 125, and I know this little baby angle's 50, 50 plus something needs to make 125 in total. 50 plus 75 makes 125. So try to set up the next example. Try to put your numbers in your picture. So in this case, it says XUY is 72 degrees. YUZ is 51 degrees. I'm trying to find XUZ. XUZ is this entire exterior angle. It's the whole angle. So instead of subtracting, what am I going to have to do? Add it. So I'm doing 72 plus 51, which makes what? Thanks. 123. So I would say the measure of angle XUZ equals 123 degrees. So those ones should be pretty easy. You're just adding or subtracting. Now we're going to get into the math stuff, the mathy math. We're going to have to write equations. So for example 7 says if the measure of angle FHI equals 142, we're finding the two interior angles, the two smaller angles. So I'm going to put this piece of information on my picture. It says FHI is 142. If I start at F, I go to H and I end at I. That's the entire angle. So this whole thing makes 142 degrees. They don't say anything else because in the picture, it says that 3x plus 6 is right here. 9x minus 8 is right here. So this is why it's similar to chapter 1. I took piece plus piece equals whole on a segment. I'm basically doing the same thing, but as an angle. So I'm going to take the small angle, add it to the other angle, and I'm going to set it equal to the whole thing, which is 142. So I'm taking 3x plus 6. I'm adding the other angle, which is 9x minus 8. And I'm setting equal to the entire degree. The whole angle is 142. And I'm going to draw my line through my equal sign just because some of you do that, which is fun. So it's keeping you organized. Now I have 4 things over here. So I'm going to combine like terms before I start moving around. So over here, I have x's that I can combine. If I combine +3 and +9, what am I bringing down? 12x. And then I also have constants or numbers. Constants are just numbers without variables. So I have 6 and I have -8. What is 6 minus 8 bringing down? -2. So I'm bringing down -2. And then I'm bringing down equals 142. You could move each thing individually, but it saves you steps if you just combine like terms on that first step. So how am I going to move the -2 to the other side? Add 2, cross them out, add 2, because what I do to one side, I do to the other side of the equal sign. So I'm going to bring down 12x equals 144. And then to solve for x, what's the last step? Divide by 12. So I get x equals 12, but I ain't done. Not done yet. Because it doesn't say find x, it says find the measure of angle FHG. FHG is not 12, x is 12. FHG is 3x plus 6. So what do I actually have to do with x? Substitute it in. So I'm going to take my angle measure, the measure of angle FHG is equal to 3x plus 6. And I'm substituting my x into this. So I'm doing 3 multiplied by 12. And I'm adding 6. PEMDAS for always and forever. PEMDAS for life. Multiplication before addition. So what's 3 times 12? 36. And if I add 6, what do I get? 42. And now let's use those brains that I know are somewhere in there. If this little angle is 42, what would the other angle be if the whole thing is 142? 100. So yes, you could take 12 and plug it into 9 times 12, subtract 8. You would get 100. Or you can think, I know the whole thing is 142. I know now this little angle is 42. So this has to be 100. So I could just write my answer as the measure of angle GHI equals 100 because I used my brain and I just subtracted 42 from 142 and got 100. So try to set up the last example. I think we need for the problem. Read the directions. So it tells you it is a right angle. A right angle. Means that it's equal to 90 degrees. So you should be doing angle plus angle equals 90. It's a right angle. So you should have 12x plus 3 plus 6x minus 3 equals 90. Because it's a right angle, so it's adding to make 90 in whole. I'm combining like terms. If I combine 12x and 6x, what am I bringing down? Ooh, not 19. 18x. So 18x. Your math is not mathing. And then if I combine 3 and -3, I'm not bringing down 6. 3 plus -3 is 0. They really just cancel each other out. They're on the same side together. They make 0, so I don't need to bring down anything in that case. So I could just bring down equals 90. What do I have to do to both sides? Divide by 18, not 19. So x equals 5. Then I'm going to substitute it back into one of the angles. So if I say JKM, the measure of JKM is technically equal to 12x plus 3. I'm taking my x, I'm substituting it back into the angle. So I'm going to do 12 times 5 plus 3. PEMDAS for always and forever. Multiplication before addition. 12 times 5 is 60. If I add 3, what is the measure of angle JKM? 63. Okay. So if I know that that's 63, if this is 63 and the whole thing makes 90, what is the measure of angle MKL? 27. Because 27 plus 63 makes a total of 90. And if that's far over your head, you could take X and plug it in and do 6 times 5 minus 3. Okay, so I'm going to pass out your classwork. You're only doing odds. All right. The first couple are just adding or subtracting. You only have to do odds. You have class time. You should get done with the portions. You know, after the people next to you, don't hurt the brain. It's easy for them. Yes, the only odds. Where the rest of these go? I'm so confused. Did I give you an extra one? No. My favorite. I'm favorite. I'm so confused. What are you doing? You're not like, four copies short. Oh, you know what? I put them in here. You guys are fast.
Yeah, anything I can.
There are only a few odds. If you want to do the eBay price credit, something I'll need to.
I'm gonna do the upstairs.
This one.
Now, my chain. She had 40s and things, I see like 340. That's possible. I knew it was going. For the like, when you get up, when you go, there's important. That's the only difference. I got it from the window.
Where's my mind? Oh, there it is. Oh, no, that's right. I just looked really small. You're good.
Not really, he was, but he was more than that. Really, all that.
You subtract it. No. Just try. Oh, yeah. So WIJ is tenant, the percentage will equal for the table. And then one point five.
All of it, you got all that extra. 8 years, bro.
Would you do what's this? Oh, because you're equal to 24. So IHC is all eight. So the whole thing, IHC is so.
You want to say, you're racing already.
Right.
So yeah, just here, it's going to time for social security. I'm not going to mess with it.
Take another.
Yeah.
What if you do? That's correct.
That was the small. That. But, well,
Oh, they're in the last statement. Or finding six will be done. All of them.
oh, haters.
So. Well, I'm focused. It seemed like one is better.
I've been reading that. Go down and that's
Number 6.
Design. Always has some sort of. Yeah, so everybody is all together too. Are you sure? Is he right? I was going with you.
Said like number 8 and then it says like. Then you can start finding. But this is all the spare copies. Starting with like.
All right. Go that way.
No, it didn't. You don't, sure. Make sure you take the point back to the casino. Yeah, I did. I have a license.
Oh, yeah.
Oh.
Catherine's right here.
That's new. Wait. Oh, something says it's very good. So you should be Dustin. You know, next time I'll see you. You see how this thunder, you added 13, you should have minus 13 to the other side. Once you have minus 13, then divide, you'll go easy. Okay? I think it's your test. Don't throw it away.
So what you're doing is once you put the difference, you're admin for starting. So you're taking 3.7,
I got it.
4, 3, as you say, it's 8.3 to add them up to base them further. Because for now, you cut all the sides. So if you find the distance, that's this, which is the distance. So you're just taking your answer from the previous number. Okay? So I would start by combining like terms. So I would do -1, 34. I would do 11x plus 23 plus -1 plus 23. And then you are moving around your equal sign, so I would combine this 23 both sides. Yeah, because you have variables. Spacing.
You want to track them. Not what? What? Yeah, the hair over here.
There you go. Do you agree? Yeah.
So this is how.
Yeah.
So basically you just added.
Yeah.
That sounds ridiculous.
For number 3.
They keep on talking about all of them. They say we should add that down.
This one here's the adding.
Yeah, and then the bottom two, because we're only having those ones you'll have. That's like the last 2 examples.
Here, hey. If you're deciding, if you're deciding them.
What we doing?
So run it out here too, if you're deciding.
What we doing?
Right.
In one?
What would I miss you? What would I miss you? Please.
Yeah, my little propagation from my planting. They're cute, yeah. I have them all over my windowsill and stuff. They'll make it feel homey.
not allowed to have pets, so there's on.
Yeah, right. Yeah, well, they're better for pets anyways. Pets are dirty.